Could any of oh, okay. It sounds like everybody's saying no audio. Okay, I'll restate what I did before. So thanks for tuning in again. We're having so many like computer problems and
YouTube
everything.
yeah.
But hopefully you watched the previous video. A cucumber was the best laser shield. Hopefully you watched that, and that's what we're going to be talking about today. And I'm just I'm looking at the chat right now to make sure that you guys can. Yep. Okay. Everybody can hear us now. So if you can restate everything that you said as well.
Sure. You know, what's funny is like with all the high-tech stuff we do, some of the most difficult problems we have is just dealing with the YouTube. But now that we're up to speed and we're only about, 15 minutes late, we'll get going. To begin with, we're going to talk about that video, but it is an open forum. So if you want to talk about any science, technology issues that are on your mind, we're open to talk about that. But I did want to give you a little bit of background about some of the things that weren't in the video and some of the comments that people had made that seem common. There's a lot of similarities in some of the comments, and I think I can address those and maybe simplify some misunderstandings. The first thing I want to bring up is, let's see where you can see it best, right here.
Yeah.
Can you see that?
Yeah, they can see that.
See the, okay. No, I was not in a bar fight. It's an interesting story because what happened was yesterday, this was after we had filmed the video and everything, my wife mentioned that I had a black eye. And I said, I do? And I'm figuring, I'm in the machine shop all the time. I'm dealing with all the dirty tools. And I figured, no, I must have just wiped my face with some dirty finger. And so I said, no, this doesn't hurt. I feel perfectly fine. She said, no, that's a black eye. So I look in the mirror and it's like, it was a black eye. And what's interesting is I don't really remember, or didn't remember at first, what could possibly have caused the black eye. Well, you see these goggles here. We wear these whenever we're working with lasers. And some of you, even when you're not working with lasers, have similar goggles with clear faces to protect you from debris or sparks when you're working in a machine shop. And the interesting commonality to these goggles is this very thin, tightly wrapped ridge that goes around the outside of the goggle, and it presses all the way around your eye like this. And you can feel it. It's a fair amount of pressure. Well, after you're wearing these things for a few hours, you kind of forget they're on. And what I realized is that at one point when I was bending over and moving these bricks and some of these heavy objects, I did bend over a little too close and bumped the side of my protective goggles and must have pushed hard enough to cause the very delicate tissue right below the eye to rupture a few blood vessels. So I must have gotten the bruise then, but didn't notice it. I didn't really feel it and didn't pay much attention until it was noticed later. So I think it's just sort of an ironic thing that you wear these things to protect your eyes, and in fact, they were the cause of my only eye injury, short of an explosion a few years ago. So we could talk about that later.
Well, and the reason you were wearing those is because of this video that we just recently.
Exactly.
It's a nice callback. But
I'm kind of assuming that most of you have seen the video, and you really should watch it because it was a lot of fun to do it. And one of the interesting things about the last few videos we've done is that they cover only a very small fraction of the work and the engineering that's involved with building this directed energy device. And it's a rather, you would think, kind of trivial aspect, the back wall of the room. But it was a deal killer because if we couldn't stop the beam, we really couldn't do the video because it would obviously be hazardous for people outside of the building. So we had to solve it, and it wasn't clear we were going to be able to come up with a good solution. And the fact that we were able to, with a very inexpensive method, was really gratifying. And it sort of evolved from some of the comments that were given in the previous videos about using water and waterfalls and using something that's got water in it. Wet is always anti-heat. And it turns out that by utilizing water but in a captive form so that we're not dealing with water that's flowing into the room and flooding the room, It's an excellent solution. I really like it, and it's going to be what we're going to use, and I'm going to be starting to fabricate some of these panels. In addition, now that we've got that handled, and I know I could put one of those things up with Alex's help, we could probably assemble the entire wall in a day or two. Now we can reach out to the smart people, and we're going to reach out back to Chris. We're going to ask him for some recommendations, but I think he may have moved on in his career, and so it may be necessary for us to connect with some other people with really good robotics and programming and computer skills to help us with the parts that I'm just weak on. Even with Alex's greater skills, robotics is that's a different field.
Yeah,
And
that's not my field. I'm okay with computers. Well, you would probably all disagree since
after the last 15 minutes.
yeah, right. But that's sort of my forte is the, computers, but not mechanical engineering or anything like
Right.
that.
And the robotics is a really interesting sort of profession because it does sort of marry the idea of mechanics, mechanical engineering. I mean, what's a robot? With all the programming and then interfacing those things practically. You know, you could understand one, you could understand the other, but if you don't have that sort of bridge, you can't visualize what can a computer control and what is a computer control able to do to mechanical devices. You know, you can't be unrealistic about structural qualities and, you know, all the components that are necessary. So anyway, robotics is what we need to finally finish the triad of the issues of the laser, the environment, and then control. And I'm going to be reaching out as soon as we get to Monday. And hopefully we're going to get some good names and some people who are enthusiastic about working on this kind of project. And we have extra goggles, so we'll be okay.
Yeah, that would always be fun having, you know, someone here in person, not just like we've talked about it, but having like a Zoom call with, you know, people. But I think it's always more fun, like when Lars was here and we had the in-person, you know,
Yeah,
discussion.
it just seems more, you know, comfortable, like you're having a real, you
Yeah.
know, conversation as opposed
Right.
to a communication. An interesting thing somebody brought up, one of the first people that we may see if we can arrange a live stream with is Nighthawk and Light. And somebody brought up in the comments, I saw his video, but he posted a video, I think it was yesterday, on using organic materials to build organic plastics. And it's a very good video. If you haven't seen it, go take a look at it because I think you'll find there's a lot of similarities to kind of the approach that we try to take, which is realistic science and engineering, not just how fancy and how big can you get. And I'm definitely going to talk to him about it if we do get him on the show. It would be fun to talk about that. The other sort of thing I wanted to bring up too is one of the issues that we're going to have with these drones and taking them down is that, practically speaking, what we're doing is we're sort of what's that thing where you know you develop a problem. I mean, they could even bring this up like, you know, the whole issue about COVID. You create the problem, then you create the solution, then you enhance the problem, and then you enhance the solution. It's a great business model.
Self-correcting or
That's kind of like the opposite. It's like self-creating a problem.
Right, okay.
Because what we're actually showing people how to do with the protection of the back wall is we're kind of showing people how to protect drones from the very devices that we're showing
Right.
people how to use with drones. But that's actually the principle, because we're not trying to create a weapon. We're trying to get everybody that is interested up to speed on what is out there and what its capabilities are, so that you don't get these fantastic science fiction views of laser devices and think they can solve all problems. They can solve a lot, but you have a sense for what they can't do as well as what they can do. And that's why we're developing this, to sort of give people that kind of information. So it doesn't really matter if we're talking about the white and the black pieces on a chessboard. We're really talking about the rules of the game, like how it's played and how the principles operate. So it's science, it's engineering, and it's educational, and it's an opportunity to cover issues like optics and mechanics and chemistry, and even environmental issues and legal issues and safety issues. So it's a blast, and that's why we're focusing on this as a major project while we do our other videos in the meantime.
Yeah, right.
Yeah. Some other kind of interesting things that we've discovered with the laser system is that Max Photonics, which is the manufacturer of a couple of these lasers, keeps upping their power levels. It's it's really kind of intimidating. They now, off the shelf, if you wanted to and you had the cash, you can buy a 120,000 watt laser that you can roll right into the room. 120,000 watts. And if you saw the video that we did this morning, that's 120 times what we used for the test against the target. With both of our lasers, we're able to achieve 3,000 watts or 3,200 watts. So the development of these fiber lasers and their progress is so fast that a lot of the principles will also change. What can be done with them. Things that would have been impractical are now almost cost effective. So it's a moving target, so to speak, with respect to developing these sorts of devices. Do you have any interesting questions or something? Because I can just keep rambling, but I don't want
to. Yeah, that's fine. There's a couple of questions here, but actually, maybe it'd be good if you want to
do what?
Take a look at any of these.
Oh, okay. Let me just take a look at this.
Yeah.
All right.
And while he looks at his phone, we appreciate all the comments and everything. So I'm not ignoring any of your comments, but we're just trying to stay on topic. That's all.
Sure. The two that I think are probably the most important, I just brought up. The tests that, power levels, the test that we were using the laser for all of our tests was 1,000 watts. And the lasers are capable of 1,600 watts, and we have two lasers. The reason we got two lasers is because we anticipated the fact that for power levels that are up in the range that would be practical as a, directed energy device, you're needing to get into the 100,000 plus watts range to be practical against practical threats. And it seemed that it would be likely that you would have to have multiple beams. So we decided to include that in the development of the engineering, two of them. If you can build it with two, you can build it with 4 or 9 or 16 or 25. The engineering is pretty similar. So that was the reason for doubling up on the lasers. But as you can see, these were bought about a year ago, and they're already up at 120,000 watts. And that's not the largest ones that are made, just to let you know. The other one is why was an MD turned engineer? I've given that history, my own history before, but like 20 seconds. I started out in physical chemistry in college and was going to go to graduate school in physical chemistry, but decided that I didn't like the isolation of only working in a laboratory, and ultimately decided that I had a lot of interest in medicine and enjoyed, the concept. And so I transferred over, even though I've retained that interest. And now, having retired from medicine, I have the freedom to explore that. And I don't think a channel based on medical information would be as broadly valuable to people, because a lot of it would be proprietary and a lot of it would be sort of too removed from their daily lives that they wouldn't find it interesting. So that's why I made that change. So let me give you your phone back.
Yeah. Well, and if you want to keep answering questions.
Okay.
Yeah.
All right.
Just because there might be another.
We're having a chat issue here with the computer, so this is a good way to do this. Yeah.
Yeah.
What we're doing here is commendable. I agree. I think we're very commendable. That's great.
Well, how about would lasers work with
Fresnel? You leave out the S. That's one thing that I had to learn. Yeah, a Fresnel lens. No, because see, Fresnel lenses, because of the fact that they have discrete shapes. If you've never seen a Fresnel, I'm sure you've seen Fresnel lenses. You might just not know that you were looking at them. Anytime you look at like LED lamps, some even fluorescent lamps, they have flat plastic surfaces in front of them that look flat on the large scale, but when you look at them, they have little ridges. And if you look carefully enough, the ridges are actually triangular. And what they do is they effectively work like you took a large curved lens and then took all of those curved surfaces and put them into the same plane, if that makes sense. So it's almost like you've got 1,000 nested lenses that have all been put into the same plane. The reason they won't work with lasers is because that discontinuity between the lenses would lead to tremendous amounts of diffraction. You'd end up getting a lot of light that doesn't end up in the final focus. That decreases efficiency, and it also means that your light beams are going to be going everywhere, not only to your side and to innocence, but also to the target that you're trying to hit. You do not want to use a Fresnel lens. But for concentrating solar power on a solar cell, or for taking light out of a discrete device like an LED and spreading it smoothly over the room, they're great. And they can be made out of plastic. They're inexpensive, great solution, but not for high energy optics. It's just like I talked about when I was talking about the chromatic aberration you have with lenses. And that's why our aiming beam seems to focus at a slightly different distance than the firing beam, because they have a different wavelength. Chromatic aberration is the difference in the focal length of a lens with light's wavelength. And that's one of the issues that you have to deal with when you're dealing with laser optics, is you can't correct that as you can in a microscope, a telescope, a camera lens, because you have to minimize the number of elements. You certainly can't glue lenses together because the heat buildup and the energy loss through the multiple additional lenses doesn't work. Keep it simple, stupid, is the better way to do it. And I think for a lot of people who have commented on the video this morning, we're done with looking for a solution. There are other, aerogels, or should we use starlight, or should we use graphite or waterfalls? We're done. We don't want to sort of keep focusing on the solution to the problem, because we've got a great solution. It's cheap, it's easy to build, it's inexpensive, it has low toxicity, it's easy to dispose of, and we know how to make it, and it clearly works. So rather than waste our time going through more materials just to kind of gain more knowledge about this subject, we've got enough to be able to move to the next stage. So I thank you for, offering these other suggestions, but we really aren't going to go down that route. We really want to focus our limited time on other interesting videos and progressing with this device. We want to get this thing working. Let me see.
Yeah, that makes sense.
Oh, and some people were asking about pulsed lasers, like why you're not using pulsed lasers. There's no real reason to do this, because pulse lasers have one very limiting factor, like femtosecond lasers, super fast pulse lasers. They produce wonderful cuts in very delicate materials, and they're very precise. But the problem is their average power is limited, because the fibers can only take a certain amount of maximum power. Not over time, I mean at any time, even for a femtosecond. You reach the limits of the glass's atomic interconnects, and they can actually create dark centers and realign the chemical structures in the glass. So high enough energies, and you will damage the fiber. So if the limit of the energy is in the pulse, and you've got a quiet time between pulses that's 99% of the time, your average output is very low. So with a moving target, something that you've got to put as much energy into as fast as you can, because you've got to move to another target, or you may lose the target because of tracking or something like that, you don't want to waste that 99% of downtime. You want a continuous beam, you want it as tight as possible, and you want it to be as powerful as possible.
Yeah, and I can read another question if you want.
Sure. Oh, and for other people, while you're reading those things, one of the other things that we are working on, for those of you who are wondering, because we keep hinting at it, is the centrifuge. We're all ready to sort of film that video, because it's done, It's working. We even shared with our Patreon people a couple of short segments that we filmed while we were testing it, getting it up to speed and proving that it didn't blow up.
Yeah, and sadly, you can't see it, but it is over there, and it's still set up there. Yeah, if you could, it is impressive, and yeah, on Patreon you'll be able to see it in detail. So
Right, and that's what we do a little bit with the Patreon as a thank you to our Patreon supporters is we provide some of the filming, which isn't all done in one step. Sometimes we film something and then we come back a couple days later as we've developed it. And so some of those filming episodes, which are rather short, are done in advance of doing the final video that you see produced. It's over time. And they're consistent enough. They're almost like video shorts. But whenever we would put video shorts up on YouTube, we got very, very few people to watch them. And in addition, we really appreciate the Patreon community because it's really providing the support that makes this possible. So we've already released, I think, 1 or 2 on the centrifuge, our initial videos.
Yep.
But the final sort of throw the whole thing together and kind of go through the detailed explanation of what's going on, we're ready to film that. So that's most likely going to be our next video. We'll hopefully get it up as soon as we can. And you'll get to see that it does work. There are some issues, things you got to watch out for. But for the most part, it's a successful project, and we'll show you how to reproduce it if you want to.
yeah. So, do you want to keep talking about this video, and you could read more comments if you want, or I might be able to.
I could. Yeah, this. I don't know what YouTube is doing. No, I love you, YouTube.
Yeah, right. You are. Yeah.
Really, because they can hurt us more than we can hurt them. Yeah, see, that's the thing. We're getting comments like the sponge. You know, somebody say you should use wet sponges and everything like that. We've got a solution. If you've seen the video, you'll see how easy it is to do. And I even, one detail that I didn't cover is it's even easier than I showed you. Since we filmed that a few days ago, I discovered that you can take the liquid that I put in the bowl initially to demonstrate in real time that this gels up. I've discovered that if you simply place the particles in the appropriate amount of water, give it a little bit of a stir, and it's still right now just a thin soup. You can pour this into the top of a completely enclosed chamber, build the entire thing, seal it up, leave the top open, and just with a bucket, pour the liquid in there. It will gel all the way from the bottom to the top. It doesn't just gel the bottom. It will go all the way to the top, and in a clear tube, it looks like you have a solid tube of glass, but it works. So it's going to be even easier to build than we thought. So we really don't need any more suggestions. You can make them. I'm not going to tell you not to, but we're not going to spend any time looking more into that. I think we really do need to move on.
Yeah.
What
okay.
I would like to hear is what other things you think it might be interesting for us to hit with a laser, not as a background target, but maybe as something that it could be useful for, not just for destruction, but something, creative. One person had asked a question whether or not you could drill a well with a laser. I know they have microwave-based well drilling equipment that can actually melt through and create a borehole, with the advantage that the microwaves produce so much heat, they actually fuse the outer layers like you're putting in a casing. The problem with a laser is you saw all the particles that were flying out of the front of this these panels, and those particles through a long borehole obviously are going to produce a lot of debris, which is going to really distribute the laser over a larger area. And so you can, but I don't think it's a cost-effective way to do it. If I was going to go high-tech, I'd go microwave. But just like people are saying that projectile weapons are a good way to take care of drones, lasers can do it too, but it's nice to have a couple of tools available to you.
Sure.
Any other questions? Or
Not that I'm not. There's obviously questions, but I was wondering if we wanted to move on to the next topic or not.
We could, if you want to. We're speaking kind of in code here because
in code. Yes.
Because we got somebody who can join us. He arrived here a little bit ago, and it might be interesting to have him come because Remember when I was originally bringing up the fact that we're going to have to contact a robotics person to help them with the lasers?
Right.
This is related to the fact that I am pretty much a computer incompetent. I'm not much better than my father was. And so the point is, we need people that have this kind of skill and have developed it over a long period of time. And you've met him before, but not for a long time. But my other son of the main presenter, Paul, arrived here a little bit ago, and he can maybe give you a little bit of insight into some of the things that he's been working on, not in robotics, not that, but just some of the computational skills that's made it possible for me to get along with all the things that we've done without really understanding enough about programming and software and everything like that.
Yeah, and like what I was saying before, it's like I'm better at anything relating to computers than you are, but it's still nothing.
It's not a high bar.
Yeah, but not compared to what he's able to do, or especially when it comes to like programming and software, aspects.
Yeah. And I've got some questions for him that I think it would be good to. Is he available? Is he going to be?
I'll go see.
All right.
I'll see if he's.
Okay.
Yeah. If you want to just
So
just give me a second.
beyond the computational stuff, one of the things that we're also going to be trying to do beside the live streams is we're also going to be trying to increase the frequency of some of our videos. And so hopefully we're going to be able to produce videos as often as a week apart, which would really be neat. We're looking at potentially involving some other people, and that might be an interesting move. So if we start to produce videos more frequently, you'll see that. So the proof will be in the pudding. But right now we've got about 4 or 5 on the table, and I don't want to hint too much at them because about half the videos we start to work on end up as a video that we end up producing. Some of them are just fails. And I can give you a list of those because you might find them as good as the ones that we actually end up producing. You good?
Yeah. Sorry.
Okay.
Sorry for the wait.
Sure. So one of the videos that was sort of an interesting fail that I had recently.
What was it?
Well, you know how we've done a lot of videos on distillation, fermentation, that sort of thing?
Yeah.
And one of the things I was interested in is whether or not we could take some of the skills that we developed in distillation and be able to create different types of substances that aren't just wine or aren't just alcoholic beverages, but things like extractions, like lemon oil that we did.
Yeah.
Your finger is still numb about. But looking at doing heat treatments or heat processes for different kinds of plastics and different types of polymers to see if we can strengthen them or change some of their properties. And what I ended up doing is taking a number of different plastics and seeing if I could infuse them with other substances, like, say, graphene. Could you actually take a finished product and somehow soak it in a graphene environment and introduce graphene, a conductive, very strong material, and turn it from a soft piece of plastic to a diamond-hard piece of material? Well, I didn't actually even tell you this story.
No,
but
I'm listening to it now, but
Okay.
it sounds like the video that we just made.
Well,
so
no, because
okay, no,
no,
why?
because what would happen is you could take, like, say, a plastic toy, a child's toy,
Yeah.
and turn this soft, squishy piece of toy into something that looks like a carbon fiber product out of a 3D printer.
Okay.
You create the hardness in the polymer after the fact. So it can be blow molded like, a milk bottle or something like that,
Okay,
and then you
okay.
infuse it.
I see.
Well, the failure was the fact that I had a temperature control system, and I was using that to allow the vapor to get onto the plastic. And just like, our initial video here, it failed. But I wasn't in the room at the time. And I had a couple of plastic items inside of the chamber, and they were supposed to be warmed up to about 80 degrees Celsius, a little below their melting point.
and
Well, the temperature monitor went to 400 degrees Celsius, and it was busted. And the smoke the smoke alarm went off, but the smoke was so thick that I couldn't find my way around the room. This was in my part of the shop. I couldn't find my way around the room to be able to pull
And it's all built out of wood.
Yeah.
Dude.
So anyway, I found the cord by tripping, and no, that's not what caused this. I found the cord by tripping and pulled it out. And then I grabbed a flashlight out of the car, found my way to the object, pulled it outside, and let it continue smoking for a couple of hours.
Yeah, it's probably good that you didn't tell me about this. Yeah.
No, I didn't. But the point is, not everything you see on the camera is a successful project. There are a lot of them that fail. So, that was something I did 2 days ago.
Yeah.
Yeah. So, in any case, is Paul going to be able to join us? Or?
Yeah, I think so.
Okay. All right, then let me shut up, and why don't you come on in, Paul?
Yeah.
Yep, he's there. Cool.
All right, hi guys. I don't know if you can see me
I
yet,
can see
but-
you now. Yeah.
I can see it. Yep. So, welcome.
And hopefully,
to the show.
and I'll adjust the framing if you need that,
Okay.
but should be good.
Yeah. This should be freed up. Okay, you're good.
Yeah, and keep
All
that
right.
on the left-hand side. Yeah.
I think the last time Paul would have been in any of our videos is if you can see behind me where my hand is sort of, let me see if I can get it right. This thing here is when we were building the tornado chamber. He was helping us because we needed three sets of hands in order to put the thing together. And I think that was the last time you would have been on any of our videos, right?
Right, and then I was in a couple of full videos that you guys did. The Christmas lights made in a lab.
Oh, yeah. Those are good.
Yeah, that one, and then the radio data sender.
Oh, yeah.
And so that was like, if you go back to the old tech ingredients videos, you'll find those videos maybe like 2 years ago, do you think?
I'd
I'm
say
gonna
More?
see if I'm
He'll
gonna
pull it
see
up.
if I can pull it up.
My guess would be about 4 or 5 years ago. But
Maybe
I'm
for
wrong.
the oldest one.
Yeah, maybe for the oldest.
Yeah.
But
Christmas lights made in a lab, I think, was only like 2 years ago, actually.
it could
was
be
more recent.
It could be.
Yeah.
I think we've got like over 100 videos, and it's kind of hard to keep
Yeah, there's a
track
lot.
of. Yeah, exactly.
Yeah. This one would it be this? I don't really.
It's hard to say. Oh, yes, that was it.
It was
That was
okay.
that. Yeah.
Yeah, how old was that?
It's difficult because I'm signed in. So
Oh, okay. Now I know with this search he's going to end up blowing up the live stream. We'll see, but
I don't think so. Ingredients. Not this one, but
No,
it'll
was
tempt me
there.
like
Yeah.
Just go to videos and roll down. You'll find it. I can find it for you. Do you want me to find it? I'll find it.
Yeah, I don't think you'll be able to
Let me
find it.
have the
But
mouse. Yeah. Let me try.
go for it.
well, as those guys fight over the mouse. Oh, okay, we can see them together. All right. So anyway, it's been a couple of years, and I was bringing up the idea of the
How do I get-
robotics that we were doing with MIT, and wondered, like, would Paul be able to do that? And he had said, no, I'm not really like into robotics. Like, I understand the programming and the software and everything like that, but robotics, that's an area that I don't really like working with. I think he probably could. But the point is, he's just not interested in it.
Here it is, right here.
Oh, okay. You did find it. Okay.
Yeah, this is it.
I
So-
totally forgot. Oh my. Yeah. Okay.
And let's see, I want to get a good picture of what we were doing. So that was our setup.
Yeah. Room
And
looks
if
the
we
same.
keep going forward, we'll see the end product at some point.
Probably the big hump near the end.
Yeah.
Yeah.
There it is.
Yeah.
Yeah.
Yeah. So they're like Christmas tree. Here you go.
Yeah,
But they're like Christmas tree bubble lights. So the bubble lights that you would find on Christmas trees,
That would hang down.
yeah,
yeah.
they would normally hang, but we made really, really large ones that are like desktop kind of style.
Yeah.
And it was really fun. It was
Yeah.
super fun.
And the reason that sort of we were discussing this, because when I brought up the idea with the robotics thing back here, and
Yeah.
Paul was saying, no, I just, it's not my forte. It's not the area I'm interested in. We started talking about just software and computers, and Alex had brought up the fact that because editing some of these long videos at 4K and a lot of the filming that we do was taking him a very long period of time. He was working, for hours and hours and hours, simply because the computer itself, with a lot of the rendering, was taking so long that with all the other manpower, you also added in that. So he started building a new computer for that purpose. And in the process, we then started talking about software. And then Paul brought up the fact that he is, really hot about certain kinds of programs. And then my eyes cross.
Yeah, so basically I'm here to talk about software engineering because I'm a software engineer. And I studied computer science at RIT, Rochester Institute of Technology. And so anyway, but the thing is I've always been into programming ever since I was like 8 or 9 years old. And I just wanted to talk about how I got into it. Because how I got into it was a very strange thing. Because it's not like one day I decided I want to get into programming or something like that. It all happened on accident. So what happened was I was upstairs on D. Well, I call my mom D, okay? Her nickname is D. So
I call her that too. So
yeah, everybody calls her D.
Everybody calls her D.
But anyway, I was on D's writing computer. So my mother is a writer. And it was a old Windows 98 PC. And, me always being curious about how, stuff works, I was going through the system folder. And so I'm working my way through the system folder, and it's like I'm going and just running random EXEs in there and just seeing what happens, which, isn't exactly a good idea, but, it's
10 years old.
yeah. Yeah.
isn't exactly.
It's not exactly
I like
a good
that.
idea. I like that, yeah.
Yeah. Yeah. So anyway, I'm running these random EXEs on Windows 98, and that's when I discover one that's called PureBasic. Okay. So I run that, and I'm looking at it, and I'm like, what is this? It looks like some kind of notepad, so I start typing into it like as if it's a text document, like Word or something like that, right? And it keeps saying syntax error, syntax error. And I'm like, why is it doing this? What is this? I remember I asked D, what does syntax mean? And she was like, oh, it has something to do with grammar or typing or something like that. And I'm like, So I go on a different PC, one that actually had the internet on it. And I looked up what that meant. And that's when I realized, oh, this is a programming language. And I was like, okay.
Kinda like this.
Yeah, it was kind of interesting. It was intriguing because it wasn't very intimidating, right? It just looked like a WordPad or like Notepad or something
Yeah,
like that.
okay.
Except a really old one, clearly for DOS.
Right.
Did you want me to pull it up now?
Yeah, in a sec, almost. It's good that you got it loaded.
Yep.
But anyway, so it's like, I pull this thing up. It looks like a Notepad type thing. I start typing in there. And, it gives me these errors. Well, I eventually find out it's a programming language. And so I start looking up the very basic commands that you can do. And what I discovered is that it's really simple and it's really easy. It's like you can get something very simple going really trivially. Like you can type in circle or something like that. And you got to give it a screen mode to use.
It's English based. In other words, English language based.
Yes,
it's
it's
not
very
just all letters and numbers and code.
Right.
Okay.
It's a very high level language.
Okay.
Right. So there's low level programming languages and then high level. So you could think of it kind of like an onion. Okay, it's like an onion. It's like at the core of the onion, you have things like binary and assembly language, stuff like that. And then on the outer level of the onion is where you have stuff like BASIC or Python or JavaScript even, kind of. Although JavaScript's maybe like the second layer down from the onion. But like it's one of the really outer layers of the onion.
And they're all operating like binary and assembly for you. In other
Right,
words,
it's
that's
converting.
what's still doing it.
It's still,
Okay.
of course, it has to convert eventually down to binary
Right.
because that's what computers are, binary.
Right.
Right, but it has to get down to that level. And there are different methods of doing that. There are interpreters, there are compilers, there are virtual machines, bytecode interpreters. There's many different kinds of processes that can be used to convert that English, more human readable stuff, that syntax, into the assembly language.
Got it. Okay.
Right? And so what is so cool about QBasic is it's a pretty high-level language on the surface, but deep down, it compiles down into assembly language pretty efficiently, so it runs pretty quickly. At least it did back in the old days. You know, nowadays there are a few better choices, like PureBasic. And PureBasic is something I want to talk about a little bit more here because it's something I really love.
Where's the
Well,
basic commonality? Why is it always called basic?
Well, it's a dialect of BASIC. Like there's many different programming languages out there, and
Okay.
BASIC just happens to be one of the ones that I really like. I really like
They
BASIC.
share some similarities. That's why they're in the
Yeah,
family
it's
of
like,
basic.
Right, it's sort
Okay.
of like a Romance language or
Okay.
something like that. You know, it has a similar kind of syntax to it.
Got it.
So yeah, so anyway, it's like you can just type in, say, screen 12, and then type in circle, and you give it a couple of coordinates. You give it the X and Y position and then the size. And then you run that, and you have like a circle on the screen, right?
Okay.
And so when I did that, I think that was the first thing I did.
As a young kid, that's got to be kind of like rewarding. Where it's
Yeah.
like I'm making the computer make a circle.
Yeah,
you know?
right. I know it's a trivial thing to do, but to be able to do that with just 2 lines of code,
Yeah.
it does make it pretty intriguing because you're like, what can I do with that? Maybe I could make a screensaver or something.
That's a question though. The coordinates that you come up with though, would that differ based on your screen resolution?
Absolutely, it would. However, in DOS, DOS is very simplistic. Okay, it only has a select few screen resolutions. Okay, it has 320 by 200, 320 by 240, and then 640 by 480.
Is that why this is not scalable?
Yes, yeah,
Yeah,
that is
and-
part of it. So so let me get into this. So we have uploaded on the screen up here a program called QB64. And so essentially what it is it's a modernized recreation of QBasic, the old DOS program that I really liked back in the day and what got me into programming. And, you know, I thought that, for this channel, Tech Ingredients, it's like a very engineering-centric channel. And I feel like, people that are engineers but, not actual programmers would probably, really appreciate languages like this, especially, because they're simplistic, but they're also incredibly powerful. And so today we're going to be looking at 2 different modern alternatives to QBasic, just because even though QBasic is good, it's from the DOS days. So there's QB64, which is a 64-bit modern recreation of QBasic that is syntax compatible, meaning you can type in the same kind of code in there as you would back in the day.
So
and it'll
somebody
do
who
the
could
same
use
thing.
QBasic could use QB64. If
Right.
they knew how to use one, they'd know how to use the other.
Right,
Okay.
exactly. So it's just a clone, except it's for modern computers.
Got it.
So there's that. But people may find that it's kind of limiting, of course, because even though it does run on modern hardware, it is trying to recreate that DOS experience.
Oh.
Okay, so in order for it to be 100% DOS compatible and all of that stuff, it's a little bit limiting in some ways. So that's why we're also going to take a look at PureBasic today. And PureBasic, I absolutely love PureBasic as a programming language. I think it's fantastic. It's incredible. And part of what makes it so good is that it goes from a super easy to understand syntax that's very, human-like, very English-like. And it takes that and compiles it all the way directly down to the lowest level of assembly language. Okay.
We're making it super fast.
Right. Thus, when you run the program, it's really fast, it's really efficient.
Can
and
I-
see, that's a rare thing.
Can I interrupt you for just 1 second? Can we clarify this for everybody? When you say it's an English, because I introduced this, an English language, it's actually compatible with any human language. It's just, it is sort of like you could program in French, right?
No,
Oh.
actually, I don't believe you can. No,
Oh, okay.
it is a French. It's made by a French guy. His name is Fred something. And I'm actually considering doing an interview with him in the future. We'll see if we're going to do that, but we might do an interview with him because he's really interesting.
So even though he's French,
But right,
because of the origins of the basic
basic
family,
is English.
is English meaning
Yeah.
English,
Yeah.
language. Okay,
Yeah.
never mind. I didn't
It
mean
is.
to interrupt. Sorry.
No, it's okay. But yeah, so anyway, the thing is what's so great about it is there's very few languages these days that go from that kind of very easy to understand syntax all the way directly down into assembly language.
Okay.
See, like for example, Python. So I really want to talk about Python because I think Python is really overused by people that are trying to teach programming or people that are trying to get people into programming. Or even when I went to university, when I went to RIT, they started me with Python. And, now that I've experienced many other programming languages, I program in C, C#, a little bit of C++, but I think it's a little overly complex. I prefer procedural languages for people that are more advanced. That's what I prefer. But anyway, the thing is there are very, very few languages that convert they bypass all of the layers of the onion, right?
And get right to the core.
To the core, right? So it goes super fast. Like something like Python is an interpreter, runs as an interpreter. So what Python does is there's actually a program written in, say, C or C++, probably, I'm guessing, written in that language that then parses your code file in Python and then tells the computer what to do via C++ or via C.
They're not the
Right.
same level of the onion.
Right. It's not. It's taking your code and it's putting it down to the level of C or C++. Then the C and C++ has to be compiled, and then it has to do its thing.
Got it.
Okay. And so it adds more steps, thus making it much slower. I've done some benchmarks on Python versus PureBasic. And what I discovered is that it's on average 42 times slower. So
On
it's
average, not
on
one
average.
bad test.
On
one
average.
narrow category.
And-
What do you think is actually the slowing function? Is it the Python to the C, or is it the C component?
Oh, no, it's not the C component.
Okay.
It's between the Python and the C. So where it's the part where C is parsing that file, that code file that you're giving it. It has to go through it and act like an interpreter, like a person
Right.
that's interpreting and talking to you in English or whatever language you're converting. It's like that. You're actually talking through a third party instead of talking directly to the CPU.
Okay.
And
That's
so,
a lot slower.
yeah.
Wow.
So Python is a lot slower. And then on top of that, it also has a syntax or a grammar. If you're not a programmer, you could think of that as grammar. It has a grammar and a type of coding style that's very esoteric, and it doesn't really translate well to learning other languages.
Okay.
Meaning like if you want to become a C programmer or JavaScript or Java or something like that, learning Python isn't really the best thing because you're not going to learn the best coding skills, the best coding practice when you program in a language like that.
It would be like
It's
the
a
distinction
scripting
between the
language.
Romance languages being also one category, and then you're learning Korean. It's like it's so
right.
different that a lot of the skills don't translate.
Right.
Okay.
Right. Like in Python, you're not going to learn about code blocks or variable types and stuff like that. Whereas something like PureBasic will get you familiar with those kind of important aspects of programming that you will find in other more traditional programming languages like C or
Right.
Java or something like that.
Right.
And so that's why I think PureBasic is like the best language in this day and age for beginners, but it's also good for like not necessarily beginners, but like people that are like engineers and they also want to be able to program, right? Or even me, I still use PureBasic a fair amount of the time. You know, I would say about a third of the software I write is PureBasic.
If I'm not dumb, but I'm dumb in computers.
Yeah.
If you were to say, sit down with me, and I was a student of yours, and you started me off, how long would it take, do you think, before I'd be competent enough to be able to use that software to maybe do fairly simple programming things like I do in my engineering here? You know, these sort of like trying to make, you know, switches operate, you know, automatically from computer timers or sensors controlling, you know, light levels, that kind of engineering type. And I'm
Okay.
making a very bad example, but you know what I mean.
You know, I know exactly what you mean. So for that kind of thing, Frank, if you don't mind, could you switch to the what you've got showing up there? Yeah, and expand that just a little bit. Like make it bigger on the display. I mean that the
Oh, this? Oh, okay.
yeah, make the window a little bigger there. Yeah, there you go. Okay. Now, can you roll down and look for serial, I believe it's called. Just roll down. Roll down. Roll down. Keep going. Oh, okay, stop. Serial port. See that right there? Serial port. Yeah. Okay, so for the kind of stuff that you would probably be doing as an engineer with this language, you'd probably be using the serial port function a lot.
Okay.
Okay, because that would be for controlling machinery
Right.
or an Arduino or something like that.
Right.
Okay, so if you roll down a little more, you'll find the commands that it offers for that purpose. Okay.
Let me see here. Okay.
So you can see is serial port, so that's like for checking if something is a serial port.
ID, timeout, status. Yeah. Data. Okay, got it. Yeah. It's a rather short list.
So yeah, because it doesn't need to, you know,
No.
you're just reading and writing data from the serial port, basically. So yeah, you know, it doesn't have to be that long or complex.
So how long do you think it would take me?
Well, it's hard to say because, you know, it depends on what you want to
I
do.
like it's like, okay. Well, what I was trying to was like, you'd never do it, or like 80 years or something like that. But what I'm trying to get across is like,
Yeah.
because when I first learned programming, it's why I got turned off to it. I was down at IIT, almost
With the
his
punch
age,
cards, right?
with punch cards.
Yeah.
And literally large cardboard boxes with thousands of punch cards in it, walking through rooms that had piles of punch card punch outs in the corners. This is how I started in programming. But I got turned off to it because of the sort of demanding, non-forgiving, non-language friendly sort of programming. It was very, very, very dry. And so I never went any further with that. But if I was to sort of like get your tutorial and you sort of try to get me up to speed, kind of like you're almost starting now with an introduction, in a month, 6 months,
Okay.
2 years, what would it take?
Well, I would say, you know, if you take a look at what's up there, yeah, this is pretty much what you'd have to be able to do. Okay. So it doesn't take that many lines of code, but of course, you know, it depends on the type of hardware that you're interfacing with. Like, say you're interfacing with an Arduino that has
Right.
a very simple function, like, say, I don't know, read data from a certain sensor or something like that. That would
data
be
from a
easy.
temperature probe and then turn
Yeah.
on and off a heater switch.
Yeah, then that would take just a few lines of code, and you could probably do it in a week or less.
I could learn how to do
yeah.
that on my own and not keep calling you.
Yeah, right.
Okay.
Yeah.
Right.
But then if you're, you know, trying to control a laser and do PWM or some sort of fancy stuff or a certain protocol that's not just like a normal serial port kind of thing,
Right.
that's going to take a lot longer.
But
Because
it
you
would
might
build
have to
on
find a
that.
library as well.
Okay, so that's the next step. It's not just more code because they've got more delicate monitors. You might say, like, I might need a library that has choices of control functions and maybe interfaces
Yeah.
with certain specific hardware.
Yeah.
Okay.
Now, I would say that At this point, PureBasic is a little bit rudimentary when it comes to interfacing with hardware type stuff like Arduino. I mean, you can, of course, you can use the serial port library that's in there. But if you want to do some more advanced stuff, I think there will be in the future, though, because, see, there is a Raspberry Pi version of PureBasic coming out.
Oh.
And I think that is if not, maybe it's already out, actually. But I think that is a really solid thing, and I hope that Fred continues to develop that more specifically, because what I think it is thus far is it's just a clone of the Windows version of PureBasic, except it runs on Raspberry Pi.
Okay.
But what I'm hoping for is that he'll add libraries to it that make it such that it will interface with the Raspberry Pi's GPIO directly.
Okay.
GPIO meaning its data interface.
Okay, so that is the distinction. It's not just the size of the Raspberry Pi versus some Intel device or something like that. It's the input-output system.
Yeah.
Priorities and numbers and everything. Okay.
Yeah.
And the
Well, if I could interrupt, I just saw like a
We got to pay attention to comments here.
a fair number of comments I saw that people were complaining about the lack of libraries for PureBasic. Is it something that exists or that you're annoyed by, or
No,
is that not
I mean,
true?
to me, I'm incredibly impressed with the number of libraries like that it has built into it already. It's got all of this stuff built into it, as you can see. And it's like, if you need third-party libraries, you can find them on the web forum. And then there are also some other external websites that have libraries as well. Now, see, I think part of what it might be, if you're having trouble finding libraries for it, is that PureBasic is kind of like, it's a very small, not super small, but it's a medium-sized, tight-knit community. And it's a very tight-knit community in the sense that if you want to find stuff for PureBasic, you go on their forum or their website or something like that, as opposed to going on GitHub. Because if you go on GitHub, which is where, programmers, they always tend to go on GitHub. If you go on GitHub, you're not going to find much when it comes to PureBasic. It's more of like its own kind of niche community. Now, of course, there's never going to be as many libraries for PureBasic as there would be for Python or for Java or JavaScript or something like that. There won't be, because it is a small language, right? But I've found that after using it for a while, there's pretty much a library for everything I need. And you'll find something on the forum if you can't find it already built in. Or if you have to, you can use a C library. So what you can do is you could go to GitHub, for example, and say compile a C library into a DLL, and then you can import those functions from the DLL into PureBasic. Okay, so kind of like you would do back in the days of VB6.
You're hacking a library is basically what you're doing, yeah.
Well, it's not really even hacking. It's meant to do that.
Oh, okay.
It's a feature. It's
okay.
So back in the days of VB6, Visual Basic 6, it's like they would do that very often, where VB6 was very lacking in terms of its built-in functions. Not even close to the kind of functions that PureBasic has built in. But what people would do is they'd take a DLL written in C, and then they would call those functions into the language. And so you can do that exact thing with PureBasic as well.
Also, what you were saying, too, is it's not a super sophisticated, and when I say sophisticated, I mean higher level language like the Python. So it's going to be interesting to a narrower audience, but that also means you're going to have a narrower support group. But because they are relatively tightly bound, they may communicate more efficiently.
Yeah, that's true. But the very first thing that you said is kind of inaccurate.
Okay.
See, PureBasic is an anomaly because you can't really designate it as a high-level language or a low-level language because it's different than anything. Because, see, it's like on the surface, it is a high-level language, right? Because it's very easy to understand. It's very human-readable. It's very digestible, right? but it compiles directly into binary, into assembly language, aka binary. Okay. So because of that, it's like it really is a low-level language at heart, but it appears as if it's a high-level language.
It's just missing
okay?
the interpreters. It's missing the middle language.
Right, and that's a good thing. Like,
Right.
that's what makes it so unique and so good, and that's why I love it so much.
So maybe high and low is actually a misnomer because high is sort of suggesting it's better, and high is
Yeah.
suggesting that it's
It's
like
not
it's
better.
superior, and low level is like cheap.
Right.
But in fact,
Yeah.
that's not. That's maybe
That's a very good point.
It's a bad syntax, or it's a bad way of like phrasing it because
Yeah.
we've just gotten used to it and we accept it. But it should be more like kind of like not a higher level, but like it's a meta language. It's a language that includes
Bare metal.
Yeah.
Bare metal language.
Yeah.
Yeah, you could say that.
Yeah.
Yeah, that's a good way. That's a very important point. Like,
Right.
I'm glad you made that point because it's like there's a lot of people, even a lot of programmers, that will use that terminology of like this is high level or this is
Right.
low level. And it's like when a non-programmer or maybe somebody that's not a super programmer hears the term low level, it's like they think, oh, that must not
It's
be
for
good.
kids.
You
Yeah,
know, it's
right.
low level. It's not good. By the way, there's actually an excellent YouTube channel called Low Level Learning, or just Low Level. I believe he used to be called Low Level Learning. Now he's called Low Level. He's like a cybersecurity expert, but he's also like a programmer. And I really like his channel because he talks about exploits, code exploits, and how people are hacking into stuff and stuff like that.
Okay.
But anyway, he calls himself Low Level. So it's kind of like, for people that don't know about it,
You'd think he's not sophisticated.
Yeah,
or
right.
He's a homeless guy, but in
Yeah.
fact,
It's
he's just
really
more
advanced.
fundamental. Right.
The lower the level you go, the more advanced it gets, because then you're dealing with binary and assembly.
Which is interesting because that's actually like how physics works. It's like we deal like in the real world is all the integration of all the physical principles in the universe, and they spend billions of dollars to try to figure out how a proton works. And you wouldn't call the proton a low-level particle. You'd call it fundamental. So it's kind of like that might be a better way to describe it, even if you want to keep the high and the low. Just go for, meta and fundamental or something like that. Then it implies extra layers, but not that the fundamental isn't any more important as a foundation.
Yeah.
It's a foundational language. It's a fundamental language. But we're getting so much into this sort of thing. I don't know if,
Are there any pertinent questions? Because I want to make sure I'm not ignoring
No, but the chat is having a field day. Some people,
going on?
some people are agreeing with you, and some people are disagreeing with you. It's like a lot of people are saying, like, why are you using PureBasic and blah blah blah, and then some
Okay.
people are saying it's like
Now-
it's a fine programming language.
Yeah, well,
So-
what
so
is
it's-
what is their complaint? Like, what's the primary complaint that you're seeing?
not just
well,
that he's
I saw
dumb,
so
but
many,
kind of like anything
just
specific.
it's stupid?
PureBasic is too niche. Don't do it.
Oh. Well,
it's similar things to that, which
it
is
needs
probably
to grow. It needs to grow because it's niche and unique in a beautiful way. It's like the demo scene. Okay, it's like PureBasic comes from the demo scene. That's why, like, when I first found PureBasic, okay, it's like I was going through the thing of it, and I assumed, oh, this is some kind of interpreter. Okay, it's like I'm just going through the file system, looking at the files that were part of it, and it's like it's an interpreter, right? But then I see FASM in there. It says FASM. FASM stands for flat assembler. Okay, and you can get there's flatassembler.net, and it's made by Thomas Greitzar or something like. He's a Polish guy, and it's an assembler. It's an assembly language assembler. And so when I saw that, it made me realize, like, oh, okay, this is serious. It's like this is not some kiddie basic language kind of scripting type thing. No, this is a real compiler, and it's made how compilers should be made. It's made in a very low-level way, right? It's not made like Python or something. But anyway, it's like there was something else I wanted to mention.
with the library thing, with the niche.
I already
thing.
mentioned that, but I was going to say something.
Well, but with regard to
It's
that
pertinent,
that
though.
niche thing or the library thing, what what duty, what action, what kind of programming result would you be looking for that you couldn't find in PureBasic? Is it just a general term saying, oh, it's too niche? Or specifically, did you look into it, try to solve a problem, and fail to be able to find the solution through PureBasic? That would be the question I would put up with any criticism or even any support. Have you ever used it? And what have you found? And if you have a specific complaint or a specific issue, then that might be fun to address. But a general one doesn't help much.
No, but I think I think what they're saying is just like the library thing. It's like it's too limited. That's all they were saying. I don't think there was any deeper meaning to it.
Well, yeah, I mean, I already addressed that in the sense that you can just import a DLL. So you have a C library DLL, and you can just use that like you would in Visual Basic or even C# or whatever language that supports importing functions from DLLs or from a dynamic lib or whatever it's called on Mac. There are different names for it. But PureBasic is great because it's also cross-platform. It works on Windows, Mac, Linux, and Raspberry Pi. And it's like usually the explanation for like why do we make programming language interpreters or virtual machines or something like how Python or C# runs, right? Like what is the advantage? Why do we do it that way? Well, we do it that way primarily for cross-platform nature so that it, has that
compile into a language that can be understood by that processor.
No, cross-platform. So
That's what I mean.
Many different processors.
Right. The interpreter selects the platform it's going to be creating the
for many different ones. Right. But the point is, so it's done that way. Okay, it's done that way for those languages in a bytecode interpreter or virtual machine or whatever. Right. But see, PureBasic does it the right way. It does it by just making a compiler for each one of those platforms and building it right. So it's designed such that it's pretty much code compatible across any platform. You can write the same code on Mac or Linux
because
or
it's already
Windows.
Down to binary.
Right. Because
it's already going down to the fundamental
it's going
language.
down to binary, and it's going down to binary this in a similar way on each platform.
Right. Okay.
Right. As opposed to building a whole virtual machine and then porting that virtual machine over to different platforms. That's the philosophy of something like C# or Java or whatever. That's how they do it. But that adds so much overhead, right?
What do you think? I mean, you obviously are a strong advocate for this. You really like the language.
Yeah, I love it.
And the thing
it
is,
was demo scene. That's what I wanted to talk a little more about that.
Okay, hold that thought. But why do you think people, like in general, this wouldn't have just taken off like gangbusters and everybody's using it? If in fact it is this good, what would you say as a devil's advocate? What would be some of the reasons?
Okay. Yeah, number one, I think the primary reason why PureBasic hasn't quite taken off is not that it's doing badly. I mean, it's doing pretty well. It's because it's got basic in the name. I think that's really what it is. Because see, PureBasic, the basic is so underrepresenting what it really is.
Yeah.
It makes it sound like it's something for kids or it's something just for learning purposes. It doesn't really. Yeah, it's not the right term. I don't know what you would call it, but it's
Well, it's the reason they did Windows. It sounds cool. Windows on a screen, Windows to see through things.
I don't know if
it was a market.
sounds cool.
Well, it's a marketing thing, is what I meant. The marketing aspect of Windows.
Well, I just wanted to interrupt because it was a while ago, but you got some pro people, so.
Okay. Well, but go to the not pro people. I want to see what the people that are against it.
I tried to save it, but I couldn't.
Okay.
I'm in a fighting mood.
No,
I just want to address.
But someone was agreeing with you about the DLLs, like being able to import the what, however you framed
import.
it.
No,
that
you got
thing.
it. You got it.
Yeah.
You got it.
Yeah.
Yeah.
I've seen what people get it. Okay, it's just random.
Demo scene, don't forget.
Yeah. And then, well, let me just talk while he's looking.
Okay.
So you asked me the question. So the name, I think the name, and then number two, I would say it's because the language of BASIC itself is kind of seen as archaic because it's been around such a long time. Yeah. It's kind of just developed this old kind of curmudgeonly sort of nature to it, even though PureBasic is not that at all. It's not that at all. It's a very modern thing. But yeah, you know, when people hear the term basic, they think of like go sub and go to.
Yeah.
You know, you probably know go to. Yeah.
Yeah, even with the punch card.
Yeah, they had go to?
Yeah, they had go
Okay,
to.
yeah, well. That's the thing. It's like when you program in Pure, yeah, I mean, you can do go to. I think they have. I see go sub up there on the screen right now, so I know they have go sub. But you don't use that kind of stuff anymore. It's just to retain backwards compatibility.
Right.
Okay. But the modern way of programming, you would never do that. So yeah, those are, I would say, the primary reasons why it just has not taken off. And oh, there's one more reason. It's proprietary. It's proprietary. And in this day and age, everything has moved to this open source kind of thing. And
So
there
wait,
are positives and negatives to that.
PureBasic isn't open source.
No, it is not open source.
Got
It
it.
is not open source. And I think that is a big negative that I don't personally mind, but a lot of people do mind. And I can understand why they do. And I would say out of the main negative things that I've listed here, that would be the one that I think is the most viable, like that I almost agree with. You know, where it's like, yeah, you know, it not being open source, you know, you can't go through the code itself. But I find that it's really solid and it works well. I've not run into any sort of like clear errors inside of the engine or inside of the compiler or something like that.
Does open source have anything to do with your ability to sell something that was built using that software? Or is it only in order to get inside of the software to see what it was doing?
You can still sell software that comes from open source stuff, but it depends on the open source license. There are many different open source licenses out there, and some of them prohibit it, some of them don't.
Okay.
But yeah, so it's a very specific kind of thing.
Okay.
But it's probably mostly for just looking over the code just to see what it's doing behind the scenes
Right,
and making
okay.
sure it's good. But there was something else I was going to mention that it's like, you know, it being, you know, something that you have to pay for like that, I think it kind of adds a certain barrier to entry, you know, because people, they want, in this day and age, you know, see, back in the day, something like PureBasic, I think would have gained traction much quicker than it would today. Because GitHub and SourceForge and these open source sites have become so large that they've just kind of drowned out all other kind of stuff out there. And so because of that, it's like, it's good because it makes programming easier in many ways. But then it's also bad for small, tight-knit things, kind of like the PureBasic, right?
Got it.
So yeah. But then there was the demo scene thing.
Right.
So the demo scene is, I don't know how many people here know about the demo scene, but I'm not a demo scene programmer. I'm not that level of a programmer. But I think the demo scene is really cool because what it's about is it's about trying to fit as much advanced graphics and cool like effects and stuff like that you can make into the smallest exe possible. Okay, so you're trying to make the exe as small as possible. Sometimes they'll have competitions where they'll say like, okay, your exe can only be 64 kilobytes or
So
something
it's
like
a philosophy, not a particularly language specific process. It's a philosophy.
that. No, it's neither.
Okay.
It's neither. It's like a competition.
But
It's
okay.
it's a game. It's yeah.
Got it.
It's
All
like
right.
a group. It's not a group that all meets together in the same building and they all know
Right.
each other and they're all friends.
Make a
and-
world-class food out of somebody's kitchen supplies, you know, that kind of thing. It's a challenge, but it's not a way to, you know, handle cooking in the future. It's a challenge. It's specific
Yeah.
to the challenge.
Yeah, but what
Okay.
I was trying to say though is that it's like not a group of people that like all know each other and stuff like that. It's kind of a
Okay.
sort of spread out, nebulous kind of group
Yeah.
over the internet. Okay.
Yeah.
And so they'll have like competitions, like you make an EXE that's 64K and it can do this and this and this or whatever. And, you know, people do their thing and they make their demo with the graphics and fun stuff.
Cool.
And yeah, so I mean, it's like the thing is you know, PureBasic kind of originates from that sort of philosophy.
Right.
Okay.
Clean,
It's-
efficient.
yeah, from very small, very clean, very efficient code. And to me, it absolutely blows my mind that like all of those libraries that you saw on the screen earlier, there's like probably 50 libraries in there. You know, there's a ton of libraries in there. Now, what you see right now is just a small subset of it. It's the ones on the right-hand side. Yeah, right there on the right-hand side. But the thing is all of that stuff is 100 megs or less. Like I believe my PureBasic installation is only about 90 megabytes, I think.
Oh, wow.
And so it just shows it's incredible because it's like with something like say Visual Studio, right? Visual Studio is about 50 gigabytes in size, okay? And I would argue that Visual Studio doesn't even have a lot of the library functions that PureBasic does. I would say PureBasic has actually more. It's got more.
Then why is it 50 gigabytes?
Then
Can you
why is Visual Studio so big? Because it's bloat. That's the bloat.
Is it like
Right,
added
it's
on
not all
features? or-
There are more features. Yes, there are more
just
features.
Unnecessarily make it 50 gigabytes.
No, they don't. They don't. There are many more features. But the point is that the number of added features does not equate to like how big it is in scale.
Has
right?
it
Like it should
changed?
be maybe it should be like 500 meg or a gig. That's what Visual Studio should be like given what it has in it.
Well,
It
it's-
shouldn't be 50
If it
gigs.
is bloat,
Yeah.
then you would expect from its inception to today,
Yeah.
it's gotten bigger.
Oh, yes, it has.
Because if it
Yeah.
functioned then,
Yeah.
that's the core.
Yeah.
Anything beyond that has to, by definition, be bloat.
Well,
because
unless
it
it's
was
additional
functioning.
functions, it could be they're adding more features and functions.
Okay.
Which, like
Yeah, all
Frank
right.
said, you know, he's right about that.
Okay.
You know,
Yeah,
it's
that's
like
true.
they are adding more stuff
Right.
for sure. You know, but it's,
Along with bloat.
but it's mostly bloat though. I think.
Yeah.
It is.
Okay.
Yeah, and so it's just incredible how small it is.
If I was to use AI
Yeah.
to sort of work with one of these,
I don't think they have AI. I haven't looked though. I don't know if they have an AI library.
that's what I was wondering. Is
Okay.
like, is that something that's going to be excluded from, say, AI developmental programming?
Oh, you mean like to help you program? With
Yeah,
AI.
exactly.
No, I've already used AI with PureBasic and it works great.
Okay.
You know, like for example, that game that I made.
The reason I asked that is
Yeah.
because you said it wasn't open source.
PureBasic itself isn't
Right.
open source, but the AI can still learn PureBasic as a language that it knows.
Okay,
It
interesting.
still can.
Okay.
It doesn't have to be open source to learn it.
Okay.
But
All right.
that's a good point, though.
Yeah.
I
okay.
mean, yeah, I guess, you know, an AI learns a language just like we would.
Yeah.
It doesn't learn it by just reading the code of the compiler or something like that
right.
and trying
Studying
to
the
figure
structure
that
of the
out.
voice box, you don't care.
You
You just
know.
listen to the words. Yeah.
Right.
Right. Okay.
Right. So that's how it does it. But anyway, that reminded me of that game that I made the other day that I showed you.
Right.
Remember that game that I had you play that it's those blocks that fall?
They're falling. You want to
from
stack it and figure out where you get the
Yeah.
most collapse.
It'd
yeah.
be nice if I could bring that up, but I can't. I didn't bring it.
What language did you use?
I use PureBasic. So
okay.
that's why I mentioned it. So what I made a game that is it's kind of like Connect 4. Okay, well, it's kind of like Tetris, kind of like Connect 4 at the same time. There's
That's true.
There's an old game called Bricks from it's an old DOS game. It's called
Yeah.
BRIX. Okay. And what it is there's these blocks, okay, that fall from the top of the screen like Tetris. They're falling down, and there's 4 different colors. There's red, green, blue, and yellow. Okay, they fall down, and they fall down in a random order, right? And what you want to do is click on the blocks that you see are 4 colors all in a row or all vertically, or I don't think there's no diagonal is not. So it's just
Okay.
horizontal or vertical, or if it's in a
Square.
cluster,
Yeah,
like
okay.
a block thing. So you click on those ones that are all the same color, and then they go poof, then they disappear, and then the blocks on top of those collapse down into it. Well, part of the reason why I made that game was just as a little like foray into what can AI do with PureBasic.
Right.
How good
Okay.
is AI with
So
PureBasic?
that game you showed me
Yeah.
was in PureBasic.
Yes.
But it was written by AI.
Yeah, I'd say 90%. 90% written by AI. Yes. Yeah.
Could
Yeah, it's incredible.
If you were to have
could-
written
could-
that.
could I
Do we have
interrupt?
super?
Yeah, 2 of them.
Sure.
Yeah, sure.
So Ali, and he's super chatted before, but he said, here, you can read it. I would use Python for anything in planning/perception, then move to C/Rust for production.
Yeah, okay. Yeah, I mean, if that's his preference, I can understand, because it's like the popularity of those things is huge,
So there's
and so
libraries
it's
and
like there's
there's
a lot of
community.
stuff for it. It's like, I don't know. Yeah, I mean, it's a preferential thing. I think it mostly comes down to preference. I do like Rust. Like Rust is another language that I think has a lot of promise, and he mentioned that there. Like Rust is a language that Low Level talks about a lot. And, he will always, in each one of his videos, he'll do a thing where he'll say, like, would Rust have fixed this? Right?
Okay.
So it's one of these things where, like, okay, if this program had been written in Rust as opposed to C or C++, because usually that's the kind of code he's looking at, and if it was written in Rust, would it have prevented this exploit from happening? Right? And I'd say good like 80 to 90% of the time, Rust would.
Okay.
Right? And so the point is that Rust is a language that it's a low-level language. Okay, so
Fundamental language.
Yeah, so it's low level. It's kind of like C, okay, or C++, except it has more safety to it. Now, there's a question between, is safety good or not? But this kind of safety is not the kind of safety that really restricts you that much. It's the type of safety that prevents exploits from happening, right? It prevents buffer overflows or other kinds of issues where you can read outside of the bounds of an array, or you can, you forget to freeze something or whatever. And it's like, preventing that kind of stuff from happening is really important
That
when you're
seems-
programming at a low level,
And you're
because people
programming
exploit that.
for production, as
Yeah,
he's saying. Like
for
things
production,
right,
yeah.
where you can't afford to just sort of like delay something. It'll break something, or it'll like to produce what you want to do. You're acting outside of the box. You're acting on something else. And so you want something that is going to be more robust to failure.
Yeah,
even though you
that's
may lose
exactly
some
what it-
flexibility or some high level,
You don't even really lose.
Python.
You don't really lose. Like, if Rust is great.
Then why use
Because-
the Python, as he said, for like interpretation?
Why use the Python? Well, it's because Python has become so
Ubiquitous?
like the lingua franca, franca or whatever, however you say
Yeah, I
it.
think it's Franca. Yeah.
Yeah, but that of the AI world, of the other kinds of like deep learning type
Okay.
stuff world, that world is all Python.
Okay.
And so I think that's probably why he's choosing Python as his
Okay.
like primary or his like experimental kind of language.
Yeah.
It's because of that. It's super popular for that kind of stuff.
What was the other one? I don't want
Yeah, another one. Thank you very much for the 5. So at Tech Ingredients, and I'm assuming this is for you since you were talking. So question for your brother/son, you. What language does he use regularly for work? If he doesn't mind me asking, also that at the end, programming. So
Vim or Emacs. Yeah.
Why don't you start with that
Oh
part?
no.
Can you explain
This
if-
guy's
'cause
not
I
gonna
don't-
like me. He's not gonna like me.
now-
I don't know if I should even answer.
Could you, well, because whether he likes you or not, could you repeat that second part? Because I don't even know what they said. Like no one in the audience.
You
if they
won't.
didn't
You
read-
won't
have no idea.
understand it.
Even if
it's
you read
Vim
it.
or Emacs, you won't understand.
Okay,
it.
you're right.
It's
Well, but I would give your opinion, like even if he's gonna be.
oh no,
pissed,
no,
it's
I'm
like-
not. I'm not ignoring him. I'm just putting your phone back here.
Yeah, no, but I'm saying,
gonna answer it.
Yeah, okay. Yeah,
Yeah.
and it'll be more fun if he is.
Yeah. Well. Okay.
No, but thanks for the 5. no.
Now,
Like,
now
no,
you're
no,
gonna get
okay.
you get your 5's worth. Okay.
The answer is C sharp. Okay. The answer is C sharp. That's my main language. Okay. And then Vim or Emacs. Yeah, I don't use either of those. I don't use either of those. I use Visual Studio.
What's the controversy? Like, why is this sort of funny and like he's not going to
It's
like
funny, and he's not gonna like it because I'm not a Linux. I mean, I use Linux. Okay, I use Linux, but I'm not a super Linux geek. Okay, I'm not one of those like, uses Vim, uses Emacs, gets into the very ergonomic kind of keyboard thing, and I don't have a problem with that. Like if that's how you want to do your thing that way, But it's like, I'm just not super into the Linux environment of programming, and that's how you program in the Linux environment primarily.
that? Okay, so it's actually a personal preference of yours because Linux is just not a favorite environment to work in.
Yeah.
Okay, not like it's a lousy environment, and some people
No.
might like it if they've been brought up on it or they're used to it.
Yeah.
Okay,
And I mean, I could get into why I prefer not to use Linux, but I think I'd rather not.
Okay.
I'd rather not.
I always thought it was the opposite, that you like preferred Linux over Windows. Like,
See,
by
well,
a
okay,
lot.
this is an interesting thing then. I don't like, I should be clear, I don't like Windows or Linux these days.
Oh, no.
See, I really,
he's
I
gonna
want
piss
a
off
new
everyone.
operating system. Now, actually, no, I think there is a certain faction of people that are in this same boat as I am.
okay.
Where it's like they're not really happy with Linux today, and they're not happy with Windows today either. Because see, Windows has become a bloat bomb. Okay, it's a bloat bomb. It's also spyware. It's got all of this stuff in there that you don't select, and it just starts auto updating or doing things. I don't like operating systems that do things behind your back. Right? I really don't like that kind of thing.
For your good.
Yeah, right. But see, Linux has become that way too. It's like I find both Windows and Linux to be like that. Linux is less like that, so I do appreciate that aspect of it. But it's like, yeah, see, I really want a new operating system, and I think that there's a lot of promise in this thing called Serenity OS. It's called Serenity OS. So if you're not aware of Serenity OS, look it up. That's my OS. Serenity OS is my OS. It's beautiful because it looks like Windows 2000. Looks like Windows 2000. It's very efficient, very small. It's written in C or C++. It's got a Unix type core to it, but it's got a Windows user interface, like an old Windows, not like Windows from today, not Windows 10 or 11. But like Windows 2000 or maybe even XP. So it has that kind of interface, and then it has the core of Unix, right? So I think it's beautiful, right? And it's like, I think that that's a project that I really want to see like explode and become like really huge, right? Because I don't like Windows or Linux.
When you say a
these days.
project, like say for example, you like this and would like this, would this project, excuse me, would such a project involve hundreds of people for 5 years to develop a system that like promoted it, produced libraries for it, found applications for it? Or is that something that one or two people working together could create? Like, I don't have any idea of the scale of these things.
You mean to create the operating system?
Yeah.
The whole thing?
Well, yeah.
Okay. Yeah, I mean that takes a while. it takes a while, but it's like it was started by one guy, Andreas. Andreas, I believe is his name. It's like a Swedish guy or something like that. So it was started by just one guy, but then it was expanded upon, and there are a lot of people in the team now. I would guess there's probably around 100 people around the world working on it. My guess. I could be off, though, because it's probably been like 2 years since I looked at that project. But I really love it. And so the point is yeah, making an entire operating system, it takes a lot of time, a lot of resources. It's not something that an individual could make an operating system that's simple, like for example, Temple OS by Terry Davis. That's a good example of a simplistic operating system that's really well written. But then I want to just finish my point. But the thing is if you want to build an operating system that's like Windows compatible, that kind of level of thing, that's going to take thousands of people for a while.
Yeah, so thanks for the 5. He was the one that commented about the VIT Emacs thing.
Was it?
And then he asked, how about Temple OS?
Oh yeah, okay. He mentioned Temple.
Why I
it's funny
interrupted,
because I just mentioned that.
That's why I
Two great
interrupted.
I didn't
because
see
it was.
I did not see that at all.
No, I know. I'm reading it to you now.
It just came up.
Yeah, it
Yeah,
just
I
came
know.
up. Yeah.
Right.
I know. That's why it's
that's
funny.
no.
You're
that's
claiming
why
to
it was,
be innocent for having like
Yeah, I think it's funny. I
Yeah,
don't-
no, but that's why I was interrupting you.
Yeah,
Not
I
that
get it.
You didn't see. Of
Because
course,
no,
you didn't see
yeah.
I
it.
get it.
That's
I
cool.
get it.
Yeah.
I get it.
No,
But yeah, it's really cool. Yeah,
and it
that's
takes that
that's
long
fun.
to develop that stuff.
Well, okay.
Go on.
I just want to make sure I don't forget my point about Temple OS.
Okay. Yeah, go on.
It's like Temple OS, is like a work of art. It's an absolute work of art because it's made in such a cool way. What it is it compiles itself on boot. For people that don't know what it is, it compiles itself on boot. So it's an OS that's open source, except you can read and change all of the source code, yourself, and then it builds itself every time you boot it up. And it boots up in just like 3 seconds or something like that. And so you can go in there, change whatever you want. Now, granted, for me, it's too advanced. It's like the code that's in there is too advanced. I mean, if I really, read through it for months and really got acquainted with it, I'm sure I could do something with it. But it's something that I don't want to take the time to like invest that much into it. But like as a concept, Temple OS is incredible because there is no other operating system that has ever been made in that way.
Boot, essentially compile on boot up would seem to me to be like an extra step each time.
It is.
Why,
That's true. It is.
Why bother? Or
Why bother?
Why doesn't anybody else?
Because it makes it super flexible in terms of, like say Linux or, Windows or whatever, they have to have a bunch of servers set up to build their operating system, right? And that process of building could take days, or at least hours, right? It takes a while. So every time they want to build a new release, it takes many hours, right? Whereas with Temple OS, it just builds itself every boot up.
So what you're
you
saying
can
is it's actually building a new release, which might be the same as the last one. But it's building a release each time you boot it up.
A release of the operating system. Yeah.
That's wild.
And so it means that you can make little tweaks here and there very, very easily. Right?
Yeah.
Almost as if the operating system was written in an interpreted language.
Yeah.
Something like Python, or for example. Like if it was written in a way that is something that you don't have to compile, it kind of hides the compilation process.
But it doesn't have the bloat or the additional waste of time of compiling it.
And that's why the compilation is pretty quick because it's not very bloated. But it's also really small though because it was written by one guy. Okay,
Yeah.
so it's not something that's viable for like the future of operating systems or something like no. It's like a hobby, right? It's a hobby project for programmers.
I see.
But the point is, though, that I think the concept behind Temple OS should be put into play in a operating system that is something that could be used more seriously. Maybe not as seriously as Windows or Mac or Linux or whatever, but something that could be used more seriously, but using that same design philosophy, I think would be a really good idea.
Yeah.
Yeah. He also wrote his own program. It's programmed in his own programming language. So he wrote his own programming language,
This guy-
and then his name was Terry Davis. He took that and then, made his OS in his own language, which then compiles itself.
Is he still around?
No, he's dead. But it's a dark story. It's a dark story.
It's an interesting thing when you say
Yeah.
a dark story, because it's kind of like a lot of these super brilliant people
Yeah.
often have like some complex history to them.
He has mental issues.
Yeah.
He had schizophrenia.
Right, but that doesn't mean that he isn't able to do some amazing things, while he's with us. So
Yeah.
I'm sorry to hear that. That is a shame, because it would be an interesting legacy if what he
Yeah.
created and then didn't, see flower if it flowered. That'd be kind of neat. Was there another one?
Yeah, I had another super chat.
Okay.
Thank you, Ali, for the 200. Not USD.
Yeah.
Are you giving it to me?
No, for Dot. It's
It's for him?
Yeah, unrelated
Oh,
to
okay.
the programming questions.
Cheeky digression regarding the laser shield. How about my laser shield gel lasagna? Okay. Layer smaller gel bits between 3 or 4 membranes or thin sheets. Then, as the back plate, use polished aluminum plate of a certain millimeters. Okay. Yeah, it's an interesting idea. Let me just give that back to you so you can hold that. Okay, that's an interesting idea. Basically, what we did, but instead of putting all of the gel in one monolithic layer, you divide it up like lasagnas with, noodles and cheese and then meat and then noodles and cheese and meat, and it sounds pretty delicious. But the point is, I'm not sure why the separation in the plane perpendicular to the laser beam, what?
Keep going.
Would be would be good, because when you think about the beam burning through, what you really want to have is, as Alex had suggested during the video, the liquid, the wet gel, can kind of settle into the holes that are formed by a previous perforation to fill them up with more liquid water. And so I don't know why front to back, or again perpendicular to the axis of the beam, would be of any disadvantage or advantage. If I had to fantasize, maybe because of leakage, but we're not seeing much leakage. It's not a real big problem. It's possible that it might also cause some gathering inside of the plastic, so that certain areas don't get as much of the gel. They may actually have an air gap. They may be isolated from the rest of the liquid. So I think, if anything, it's probably a negative or just more work. So that's why we didn't do it. It's, again, the KISS theory. I think what we've got, just doing it very simplistically, is great. And somebody else that brought up screws to stabilize the walls, I avoided that, even though it was very tempting, simply because those are metal reflective objects. And you don't want the screw to be hit by some laser beam, bad luck, and it fires back into the room. So glue is the way to go.
I just wanted to mention vermaculite.
Yeah.
What do you think about that idea?
I tried it, and what happened was it didn't hold on to because it's not soluble.
Yeah.
It's sort of like a particle. It's a suspension.
Yeah.
And so what ends up happening is you get the water in there and you get the vermaculite in there. And when I did this in some cups and some beakers, what happens is the vermaculite and the water, because of their different densities, separated. So what I'd probably end up with is a large panel with vermaculite on the bottom third and then water above it. And if I fill it all the way up with vermiculite, I think it's vermiculite, and you pour water in it, it's going to displace some of the water that is really what's doing the job. So you're just going to probably lose the value of the water. The reason for the gel is really to keep it from popping out of the holes like the soda can.
Yeah. And then my one other idea was the gel, except put those little beads that you put in the bottom of a fish tank, to kind of break the beam up and make it diffuse throughout the gel.
That's what I thought the nanoparticles would do.
Okay.
And that's what I thought the concrete would do.
Okay.
And
Well, concrete isn't like reflective though.
it isn't until you rupture it with a beam and throw it into the material.
okay.
That was, again, my theory.
Yeah.
I was wrong. because it turns out it doesn't help. If it does, it's within the noise.
Okay.
And so putting in the concrete adds weight, doesn't improve the performance.
Yeah.
Put in the powders to cause it to diffuse like a cloud or a fog instead of through the clear material.
Yeah.
Didn't help. Now, it might be if we just burned it for 25 minutes, we might eventually get through it and find out
Yeah.
that the particles are better.
Yeah.
But again, it's another step. It's another material that's going to be like, thrown at us as a vapor and, contaminate the environment. So ultimately, all of my bright ideas, they were, worth testing, but they didn't help.
Well,
Just
I mean, do you think it's still worth a try, like from a fish tank store, to just get some of that?
it could be a
The
fun,
translucent kind.
Yeah, I know what you mean. It could, but I think ultimately, what I was saying earlier on, I don't know if you had arrived by this time, but what I was saying earlier on is, with a limited amount of time and limited staff,
Yeah.
I really want to get this laser taking drones out of the air. I want to get it going as fast as I
Yeah.
can. So what I wanted is something that would block the beam, make
Yeah.
it possible for us to move forward. I've got a great solution. It's cheap, and I could build that in a couple of days. Now I need to get to the next step. So for fun, sometime on a weekend, we could take a few objects and sort of fire it up. It takes 3 minutes to get the beam going. We could try a few of those things. We could do this. And ultimately, I might find that, in that discovery, maybe we find something that's such an effective blocker that we show drones how to protect themselves from lasers. So that's the other aspect of this. And as I brought up before, I'm not on either side in any kind of battle. I'm just for knowledge. So it might be worth it. And if we came up with, say, some sort of odd modification that doubled or tripled the efficiency and lowered the weight, that would then be what you put up on the drone as opposed to the back wall back there to protect it from the laser. So we keep, it's that business where you create the problem, then you solve it.
Yeah.
So,
All right. Any questions for either
yeah,
of us?
any of us, any
No,
questions?
It was mostly just like compliments or criticisms, but like pretty much back and forth. And we haven't had a super chat in a while.
Okay.
And if there's, like, you can read that if you
Yeah,
want.
just
Well,
wanna-
while-
If there's
wanna take a
anything that
look
you
here.
can,
Well,
Oh,
actually,
Zojo. He talks about Zojo. Okay. Yeah. Yeah, Zojo is kind of like Visual Basic. It's not bad. I briefly looked at it. I think it's not bad because it is compiled. But I do still prefer PureBasic to that, though.
maybe if we're slowing down and we're kind of thinking we might close this down
Yeah.
relatively soon, there's a few things I wanted to say.
okay.
One is, I think you mentioned this, Paul, but just sort of in passing, but
Yeah.
we should probably more formally say it.
Yeah.
Are you going to reach out to the gentleman that
That's a
had...
good question.
Yeah. Yes. We'll see if he might come on. Fred, the guy that made PureBasic. Yeah, I'm thinking about doing an interview with him.
So we might do
So-
a Zoom interview with him, and he's
Yeah.
not in the U.S. He's in
France. Yeah.
So that may affect our timing a little bit, maybe with a live stream, or maybe he's a night owl, and that won't be a problem. The other one is, I'm pretty sure we're not going to do another video release next Saturday morning. We might have a video that's very close to ready, but I wouldn't trust it. And so you could check back and just see. And if there is a video that would be released, it'd be released at 11 o'clock a week from today, next Saturday. But odds are it's going to be the following week. I don't think, unless he agreed or we talked to Nighthawk and Light, and somebody wants to do a video next, or like a Zoom call or an interview, I don't think we would do a live stream next Saturday. Do you see any reason why? I'm just trying to give people an idea of what the schedule
No,
would be.
I probably wouldn't unless
Okay,
Fred
unless the
responds.
Fred guy-
Unless-
yeah, if
if
I
he
can get-
responds like super quickly, and
Yeah.
then I'd be fine with doing
Yeah,
that.
I would be too.
Okay.
So maybe you could find out in that case, and then
Yeah,
if
okay.
he's going to do that, then we can put out some notifications. So it's probably worth looking, just in case, because we've got a couple people that might say, "Yeah, right away tomorrow." So if that's the case, keep an eye, because we won't release a video in that morning, but we may have a very interesting live stream. So that's probably worth keeping your eyes on for next Saturday. So
Yeah.
yeah.
And so thanks everybody
Yeah.
for tuning in. And Paul, this is the first one, but probably not the the last. So
Yeah,
And you
well,
should
thanks
also
for having me.
Thank Linda too, because nobody saw her. You know, she's been moderating this thing for a while. That's been
yeah,
kind of nice.
yeah, no, and we definitely appreciate her. Yeah, thank you.
Thanks,
for-
Linda. Really appreciate it too.
Oh,
and for the time and everything. Yeah, what?
before we go though, did Linda have any specific questions that she might have pulled out of the chat? Anything that would be pertinent?
I got a couple emails and I read them already. So
okay.
we're all good there.
So we're all good.
Okay.
Okay. Well, thanks, Paul. That was a lot of fun. Appreciate it.
Yep, you're
Yep.
welcome.
You're
Yeah, it was
welcome anytime, and especially if you got people you can bring in too. Yeah. So
Yeah, so everybody have a good night. And
Yep.
thanks for tuning in.
stay safe, and we'll see you soon.
Bye.
Bye.